Hi, it's me again, Dave Mendlen, product manager for Visual Basic. I'm here joined with Mike Pizzo, and Mike will be presenting ADO Plus and our data strategy. Before we walk into the presentation, we thought we'd change it up a little bit and actually do a demonstration of the technology first, and that'll give us some context as Mike drills down to the topics. Let's start the demo. And before we jump into Visual Studio, the first thing we should do is take a look at a piece of XML. XML is key to this Microsoft Visual Studio 7 ADO Plus technology. XML enables interoperability, enables us to share data from one platform to another. We're looking at a customer, mycustomers.xml, and I've opened it in Internet Explorer 5. And obviously it lets me see my XML and color-coded syntax, and I can navigate my hierarchy. In this case, I've got a customer object called Bradley Bismarck, who's got orders, and they have order details. And so you can imagine a relational table, a relational database that has these tables: customers, orders, and order details. Now we want to show how easy it is to use XML in your applications as you program data with ADO Plus and Visual Studio. So I'll simply drag and drop my XML file into Visual Studio, and now that file is available to me. And if I were to open it up, it'll actually prompt me for schema. It notices that my XML file doesn't have a reference to a schema file, nor does it have schema embedded in it directly. So it can actually infer the schema from my XML data. And so it's created an XML file, a schema file that describes the XML. And that's going to enable me to use this powerful XML editor. In Visual Studio 7, we've got IntelliSense for both HTML and for XML that enables HTML IntelliSense and HTML statement completion, as well as XML statement completion and IntelliSense. So because we know about the schema, I can actually, if I click open bracket, it knows that the top level object is a customer, and if I pick that and close it, it'll automatically close my tag for me. And if I want to add add a field that exists in my customer object, I simply open a bracket, and it'll provide the list of objects that make sense for customers: credit limit, first name, last name, or an order. So it's really that simple to work against XML directly in the environment. Now this is one way of working with XML. However, I prefer working in a more visual way than working with the text. So there's actually a schema designer that's based on the visual database tools. So we have a visual way of working with data and with our design. So you can see we have a customer object, an order entry object, and an order detail object. And you can see the columns and the data types, and you can change those here live. And when you save the file, it actually persists those changes out to our XML file. So not only can you modify your XML in a graphical way, you may occasionally want to look at data. So if I click on the Data tab, you'll actually be able to look at the results of a customer query in a WinForm grid. Now this grid behaves in a way that lets you navigate hierarchies of ADO Plus datasets, or XML. So in this case, we're looking at all of our customer objects, and if you wanted to drill down into orders, you can simply expand out and click on a particular customer's orders. Now the behavior that you see here is the default behavior for WinForm grids, so that you can have the same functionality for your customers as well. So if I click, and I'll drill down into order details, and you look at the details for a particular order for Bradley Bismarck. So this XML has the data I'm looking for. It's designed the way I'm looking for it. I'm going to go ahead and close and save. I'm going to go back into Visual Studio. We've had an error closing that file. So I'll save my project. We'll go back into our web service. And now what I'm going to do is I'm going to actually use a snippet of code. What we're going to do is we're going to program against XML. And one of the nice things about ADO Plus is that it lets us program against our objects. Instead of having to program to record sets and fields and indexes, you can program against customers and orders and order details. So you'll see I'll drag a snippet of code in from the toolbox again. And I've defined a new instance of a customer's data set. Now that's the file that got created automatically for me when I brought up the XML designer. That's the schema that was inferred from my XML. And so now that I've created a relationship to that XML file, I can actually program against my objects. I can program to the first customer, the first order of that customer. I can look at the details of that order and actually find the first item's price. So you can see how simple it is to program against your objects as opposed to using the ADO objects that you're familiar with. It's going to make it easier to build applications because you're programming against the business objects that you're working with. So in this example, I've created an instance of a data set, and then I'm reading in from an XML file. And basically what the last line does is it just emits the XML that we created back out. So if I save the project and I'll build, it's going to build a web service. It's going to compile the project, and it's going to publish that web service out to our website. So let's test to see whether or not, see how that worked. And my project is called Get Data. And you can see that it's actually bringing back the XML file. What we're going to do now is we're actually going to change the XML file in our second step. We're going to emit out not just any record. We're going to change the data that comes back. So I'll just highlight this, and I'll add a different public function. In this case, we're going to change the first record, the first name of the first record to Steve, and the last name of the first record to Bomber. We'll accept those changes, and we'll emit that out. So I'll save and build. And now let's go ahead and test that again. And you can see we're returning back Steve Bomber. So now that we're emitting out XML natively, what we want to do is connect this XML, this web service that's exposing XML data, to a web form application. So let's go open another project I've got open, and it's got a web form. And what I'm going to do is connect to the web service that's been exposed using the Server Explorer to the web service we just created. And it's called Get Data. So I'll add that to my project. And now I've got a reference to my web service. What I want to do now is use a data form wizard that's going to create for me a connection to that web service. We're actually going to be building a 3-tier application where we're connecting to XML through a web service and connecting that to a web form. So I'll drag the data wizard onto my design surface, and it's going to let me pick whether or not I'm going to work directly with a database or with a web service, a middle-tier business object. So I'll pick web service and click OK. And now I have created a reference, the data references that I need to work with data with this web form. So now I'm going to drag a web data grid to my web form. And I want to bind that to my web service. So I'll bring up the property page for my data grid, and it's already bound, the page is already bound to my web service. And you can see there are 3 objects here: customer objects, order objects, and order entry objects. I'm going to use my customer object. And now it's connected my grid to that web service. What I need to do now is there's a little snippet of code that I need to add in this particular build. This won't be required for when we ship this thing, but there's a little hack we need to do here and here in the form load event. And now that I've done that, I should be able to run the application and test it out. Oops. Forgot to set my start page. And there it is. There's our grid. Now that grid has been connected to a web service, and that web service was emitting ADO plus XML data, and we've bound it directly into the grid. So with that, let's turn it over back to Mike Pizzo.
Thanks, Dave. My name is Mike Pizzo. I'm a senior program manager in the web data group, and I've been working along with the European Tools folks for the last year or so to define exactly what the data model is in this new web platform. Before getting into the details of ADO+, I wanted to talk a little bit about the problem space. That is, when we started to design this data architecture, what were the issues that we wanted to address? The first obvious issue is the internet has really changed everything. All of the data access technologies that we've designed in the past, including DBLib, ODBC, LadyB, ADO, DAO, RDO, were designed initially as a client-server model and were extended in order to work on the web, but they weren't designed with the web in mind. And the web has certain aspects about it that really need to be taken into consideration from the beginning when you're designing a good data architecture for it. And the first of these is that the web is a fundamentally distributed architecture. There are multiple tiers, and you want to be able to work with data on each of those tiers in a manner appropriate to that tier, but yet consistent across the tiers. And we didn't really have a good way to do that previously. Fundamental to building scalable applications on the web is the concept of handling state. We used to say that the web is stateless, but that's not really true. There is state, and the key is managing that state intelligently so that you can scale, so that your applications work well. Finally, the point that data is still heterogeneous. In fact, with the internet, data is even more heterogeneous than ever. You've got data from multiple different databases, and increasingly a new type of data called XML. XML has really sort of taken the internet by storm and emerged as the de facto standard for exchanging information. And we didn't have a good architecture that integrated from the very beginning working with XML. So our vision for this ADO Plus architecture is to take what we know and love in ADO and evolve it and extend it, exploiting XML and its inherent scalability and interoperability to build really scalable, interoperable applications that work well on this web platform. ADO Plus is part of the common infrastructure that makes up the web services platform. On top of it is built all of the Visual Studio enterprise frameworks and the design stuff that Dave demoed just a moment ago. This picture shows a little bit about what it looks like to use ADO, and you've gotten a little bit of impression of that from Dave's presentation. But just to recap at a high box diagram level, what we're doing is you have a business tier, and the business tier is able to access data, either from a database in a data tier, an XML file. It doesn't really matter where the data comes from. The data is moved into something called a data set. Once the data is in the data set on the middle tier, in the business tier, different components can interoperate with that data, can format it correctly, and then send it down to the presentation tier. And it's sent to the presentation tier as XML. And again, XML is fundamental to our data architecture in ADO+. The presentation tier may be a Win form, it may be a web form, or it may even be another business that's exchanging information via business-to-business XML, for instance, through BizTalk. The fact that the data object is inherently XML means that it's very easy to exchange between the business tier and the presentation tier, regardless of when it's on the presentation tier, if it's being used as a data set or just as XML in the BizTalk case. Some of the scenarios enabled by ADO Plus include the ability to easily build stateless and scalable web applications. Again, this is one of the driving factors of this entire platform. Because ADO Plus is built on and around XML, ADO Plus is able to interoperate and work well with any platform that speaks XML, which is to say, with any platform. ADO Plus is able to read in any XML, so it can get XML from any platform, from any service. Once it gets that XML, ADO Plus allows you to work with that XML either as relational data through tables, rows, and columns, or as an XML tree, and then to save that back out and send it back to the server, back where you got it, or on to another component in pipeline without losing any of the fidelity of that initial XML. And we'll see in the coming slides exactly how that works. Finally, the ADO Plus architecture, as you saw in Dave's demo, allows you to program against your objects rather than coding against a different programming model when you're using data. That is, traditionally, if you look at an application, there's part of the application that works with the UI and the binding and file save, and it's all consistent in its programming model. But then there's a part of the application that actually has to deal with data, and it looks very different. It deals with abstract concepts like a record set or a row set. So a large part of what we've done with ADO Plus is integrate data into the programming model so that you can do something like access the first customer's orders and then look up an order by order ID and get the order amount as strongly typed through an object model as opposed to by binding in an ad hoc manner to tables and columns. This slide is sort of a high-level block diagram of what the ADO Plus technology looks like. On the left-hand side, we have the data components within the ADO Plus technology. It starts with the data store, and then we have something called a managed data provider. The managed data provider is able to talk to the database and expose the data, expose connections and commands. We'll go into this in a lot more detail, but basically it's the connection with the data store. We have a cache object called the data set, and the data set can be thought of a client cache, and we'll go in a great detail to what that means. But at this level, it's important to understand that the data set is a cache that may be served by the data provider. That is, it's a place where the data provider can put data from the database in order for the application to work with and manage. On the right-hand side, we have our XML-based services. We have the ability to read, write XML at a parser level, at a stream level. You can either read that directly or you can put it into an XML document. The XML document is the equivalent of what we have in the native world called the DOM or MS-XML. That gives you ability to cache XML data and work with it as nodes, as a tree of nodes. Once you have data in the XML document, you can apply common services to it, for instance, validation services or transformation services such as XSLT. So we really have this model where we have a relational cache and a data document, which is an XML cache. But what we're able to do is synchronize those two caches so that, in fact, you can work with the same data as either XML or as relational data through the data set. And we'll see how that works in a moment. But first, let's talk a little bit more about the data set itself. As I said, the data set is a common client data store. It is a relational view, and this diagram shows that it has tables, columns, constraints, rows, and relationships. So it's a multi-table relational cache that the user can use in order to store and manage data. That data itself may come from a database, it may come from an XML file, or it may be just application data. That is, the user can create a data set from scratch, create tables in that data set, push data into it, and use it just as a standalone client cache. There's some fundamental concepts of the data set that are important to understand in order to really appreciate the data set as a common client data store. The first is that it's an explicit cache model. And this varies a little bit from what we had with ADO and the record set. In ADO, you had the concept of a record set, which may be connected to the database. It may be a separate client cache, or it may be a server cursor. The problem with that is that you never quite knew what functionality you had or what performance characteristics you were going to get when you're accessing the data. It varied greatly upon the implementation of that record set. By defining an explicit cache that has no knowledge of where the data in it came from, we are able to define an architecture where you have a consistent programming model, consistent behavior, consistent functionality when you're working with the data, regardless of where it's sourced from and the destination of the data. In addition, by having this common explicit cache, you're able to have a much more integrated programming model when working with that data. We're able to expose array-like indexing because we know exactly how many rows are in the data in the cache at any one time. I want to talk a little bit about data as XML, because one of the major things we've done in this platform is really to integrate the concepts of data and the concept of XML. The data set knows about XML. The data set, as we saw in Dave's presentation, knows how to load XML as data. It knows how to expose the structured XML as tables, rows and columns, and relationships in sort of a normalized view. That is, the data set itself, if you read XML into it, will understand the structure of it, either according to a schema that you've specified manually or that you've inferred from the XML as you've read it in, and create tables and columns out of it. You can now work with that data as relational data, and at a later point, you can save that data out as XML to pass it off to another control, which may or may not know about the relational representation that you used in order to modify the data. When you load data into the data set and load data out of the data set, it's important to understand that the data set normalizes the XML. That is, it's going to not keep track of element ordering and not keep track of white space. Certain annotations that don't map to the relational structure that you've given the data set are lost. Basically, when you load XML into the data set, what you're saying is, what is interesting to me about the data is how it maps to my relational view. The data set also is able to load and save its structure, the schema, the tables, columns, relations within the data set as XML through an XSD file. That is, given an XSD file, we can create a data set and infer the tables, rows, and columns from the schema of the XSD file. And given any data set, regardless of how the tables, rows, and columns were created, we can persist that out as an XSD file. Let's look at it from the other point of view, and that is XML as data. The XML document, and specifically the XML data document implementation of the XML document, is able to store structured data in a data set. What that means is when you load XML into the XML document, which is the XML cache in the new framework, the XML data document is able to take and map the structured portion of that XML to a data set. So if you've got an XML file that may be partially structured and partially unstructured, and you're just interested in working with a structured portion. A common example of this is a pipeline, where you've got a component in a pipeline that takes and looks just at the order entry subsection of an overall XML file. It doesn't have to understand the whole XML file or expose the whole XML file to that component within the pipeline. It's able to expose just the relational, structured, mapped subset of that XML and let you work with that, modify it, bind to it, work with it as a data set, and save it back out without losing any of the fidelity. So this is a mechanism you would use if you wanted to load in some XML, work with it, and save it out without normalizing the XML. This allows you to simultaneously expose data both relationally and as an XML structure, either because you have multiple components that are working on the same data, one written to XML and one written to a relational model, or because you want to expose just a relational structured subset mapping on top of the XML. This is important. This is something we don't have very well today in the native world, is the ability to work with data either as XML or relationally and move back and forth seamlessly between the two representations. The final thing saving the XML in a data set allows us to do is actually optimize the storage. Where we know the data is structured, we can optimize both how it's stored and how it's indexed, both for doing relational queries as well as XPath queries over the data. I talked a little bit about data providers before, and data providers, again, are the managed equivalent of an OLADB provider today. However, today, in the native world, we have a dichotomy between the provider interface and the consumer interface. And that's forced on us because we don't have, in the unmanaged world, something along the lines of the common language subset. This new web platform and its common language subset gives us the ability to expose ADO-like connections and commands directly on top of the native managed data provider. So it's a very familiar ADO programming model for accessing these managed providers. The you can use connections and commands, and we have something called a data reader, which gives you a forward-only, read-only stream over the data for very efficient non-cache stream access. It's equivalent to a forward-only, read-only record set. The managed data providers also know how to work with a data set. That is, the data set provides the cache, and the managed data provider knows how to push data into the cache to let the user work with the data through the common programming model, and then take the changes from that data set and propagate them back to the back end. The data set is able to do that, or the data provider is able to do that either through automatically generated insert and update delete commands, much like the client record set does today, but it's an open model that lets you actually specify what insert, update, delete commands you want to use. So for instance, if your back-end logic uses stored procedures in order to do your updates and inserts, you can actually specify what stored procedures to call, and then the managed data provider will automatically use those stored procedures in order to propagate changes from your data set back to the back end. The final point on the managed data providers is that they're designed to be highly scalable. Again, this is important in the internet environment, that all of the components that we built are highly scalable. They're asynchronous, and they are designed to have a minimum level of abstraction. Just a little bit about common services. One of the advantages of this data model that allows you to seamlessly go back and forth between an XML and a relational representation is that all of the services written to either the relational view, such as data binding, or the XML view, such as transformations and validation, are now able to work over any data that you have. XSL transformations give you an easy way to transform data, XML data, using an XSLT document. Validation allows you to validate using DTDs, XSD schema, or XDR schema to validate that your data is valid according to some specified rules. The point here is that since we have this tight integration between the relational view and the XML view, even if your data comes in relationally through a database or is put in as application data, you can still use these common services, these XML services such as transformations and validation against your data. So finally, ADO Plus makes it easy to build scalable web applications by defining the data model that is a distributed, disconnected data model. It's XML to the core. That is, not only is it able to take advantage of XML for interoperability, but it's able to use XML components over whatever data you may have. The ADO Plus architecture is built on a familiar ADO programming model, so it should be a natural extension of what people are used to using today, and allows you to program against your objects, whether they're sourced from XML, relational data, or fabricated data. And that's the end of the presentation, and we'll take any questions at this point.
Okay, I guess it's pretty much the end of the day on the East Coast, so we only have basically just one question.
Great.
In an N-tier world, does parsing and unparsing XML between tiers impact performance? And the second part to this question is, what has been done to optimize this process?
Okay, that's a great question. In an N-tier environment, you are, by definition, moving data between the tiers. And moving data between the tiers means that in some way it is packaged, moved, and unpackaged. Be that some binary protocol, some text protocol, or any other protocol. So the fact that we're using XML as the protocol in order to move data from tier to tier doesn't fundamentally mean that there's extra overhead. XML is a text format. Because it's a text format, it's more verbose perhaps than a binary format. But what we found in doing tests of scalability in different architectures is that the real bottleneck is not usually in the amount of data transferred, which would be a major difference between binary and text formats, but in the processing of the data, how programming intensive it is in order to do the parsing and unparsing. Because XML is a well-defined format for how the data is built, and because we are designing these stream-level interfaces for reading and writing XML, in fact, we've done quite a bit to optimize how how that format is written to the wire and read from the wire in order to change it between tiers. We're not caching it when we don't need to cache it. So it turns out to be a fairly efficient mechanism for moving data between the different tiers.
And just kind of a response by someone on the chat line who commented on this, and his view is the advantage of XML is interoperability. If you use a different format that is more performance-oriented, then you potentially no longer can interoperate with other components. And the follow-up question then is, sure, that's how I understand it, but does this mean that ADO is less performant?
Great. So, and again, the point is very well taken, and I didn't mention it because it seemed fundamental, but absolutely XML is the direction that we've taken because of its interoperability, and we described that in the presentation. The follow-up question, is ADO less performant because it uses XML? It's important to note that the connected mechanism, that is the managed data providers that I described, are talking directly to the database through database-specific protocols. So for instance, we'll have a SQL Server managed provider that talks to SQL Server using TDS. So the ability to connect to a database from the business tier to the data tier, work with the data, query data, read results, and even push data back to the back end doesn't have to go through XML when you have a connection to the database. Where XML becomes important is where you're moving data between the tiers. Today, the way that we do that is by taking a record set and persisting that record set to a format that we've defined, moving that across the web, and then rematerializing it on the client. And that's exactly the same as the mechanism we have today, except for instead of using an internal proprietary format for that, we're now using a standard format, which is XML. So the things that you do today with ADO work pretty much the same way. So you're not incurring a penalty for those. What we've enabled you to do is achieve a new level of interoperability simply by standardizing using XML on how data is moved between the different tiers.
Okay, and I guess that is it. Thank you very much, Mike.
Thank you.